Okay, welcome to our first video in our flipped classroom video homework. Today we're going to focus on the periodic table, how it was kind of created, and some of the general trends and patterns we see and what we can learn from it. So we're going to go ahead and get started. First things first, we're going to start with our objectives. These are the things that you should be able to do after watching this video and, of course, reviewing your notes. I can explain how Mendeleev contributed to the periodic table. I can identify groups and periods on the periodic table. I can use the periodic table to find out the number of electrons, protons, and neutrons in an element's atom. I can describe how the periodic table is organized. And we are going to get to all of that. Be sure to remember as we're watching this video that you are taking detailed notes using color to differentiate different parts of the notes, whether it's vocabulary, definitions, illustrations, diagrams, whatever. I will be checking your notes as part of your homework completion. And after you finish your notes, I encourage you to, if you need to, go back and review the video, rewatch clips of it. And then once you feel like you've got a good understanding, make sure you do a reflection. You can choose from any of those reflections in that list we got at the beginning of the year. Both the notes and the reflection will contribute to whether the homework is completed. Okay, so let's do a quick review. We learned an element is a pure substance made of the same type of atoms. And atoms are the smallest part of an element and they have two regions, the nucleus and the electron cloud. Okay, talking about atomic structure. The nucleus is the center of the atom. It contains most of the mass. The positively charged protons and the neutral neutrons, they have no charge, are here in the nucleus. And that's where most of the mass of the atom is. Surrounding the nucleus is the electron cloud. And while that does not have as much mass, because electrons are so tiny, they do take up most of the space. The protons and neutrons stay packed in that nucleus, but the electrons move in a large cloud around it. Remember, we had the analogy of the frozen pea on the pitcher's mound, and then the stadium was the range of the electron cloud. The electron cloud, of course, contains the negatively charged electrons, and they have almost no mass. A couple of terms that we need to go over that will make a lot of sense as we go throughout this video, and it'll help you to understand. The atomic number. This is the number that identifies an element, and it tells us how many protons are in the nucleus of atoms that make that element. Remember, all atoms of an element are the same. So all nuclei of carbon, the element carbon, will have the same number of protons. The atomic mass is the weight of the average number of protons and neutrons in an atom. So if we added up the weight of the protons, neutrons, and electrons, that would get us the atomic mass. And we measure those in atomic mass units. 1 proton is equal to 1 AMU, 1 neutron is equal to 1 AMU, and 1 electron is 1/2000th of an AMU. So that's why they take up very little mass. Okay, so in the beginning, we're back 1869, in the beginning of kind of the period of chemistry here. There were only 63 elements that had been identified at the time. Of course, the rest all existed, they just hadn't been identified. Scientists worked to kind of find some pattern or organization to that, and the Russian scientist Dmitry Mendeleev, he began kind of playing with the arrangements of the elements and noticed some patterns in the relationships and in the way they kind of progressed. And so he was able to come up with a table of the elements where the patterns kind of flowed. And he said that any unknown elements in the pattern, we knew that something had to go there because there was a gap in the pattern. And he said that that could be predicted by the properties of the elements around the missing elements. So he predicted the discovery of unknown elements. He didn't know they existed, but he knew they had to because they needed to fit and fill those gaps in the pattern. After him, English physicist Henry Moseley, 1914, he rearranged the pattern by atomic number. Mendeleev started by arranging the elements by atomic mass. Remember, that's the weight of the protons, neutrons, and electrons. Instead, Moseley rearranged the elements in order of atomic number, and he recognized that the periodic pattern of the elements really depended on that atomic number, so things fell into place just a little bit better. And when we say periodic, that means repeated cycles, patterns, things repeat at regular intervals. So by arranging everything in terms of atomic number, or how many protons everything had, it made a lot more sense and flowed a little bit better. Okay, so here we have the periodic table. And we have some different parts of the table. All columns are called groups, or sometimes families. There are 18 groups in the periodic table, and we focus on kind of these main parts up here. It's kind of like the 48, the continental United States, and down here is Alaska and Hawaii. We focus on these parts up here, and there are 18 groups. Rows of the periodic table are called periods, and there are 7 of those in the periodic table. There are 3 different types of elements. Metals are to the left of this pink stair step. I made it pink so you could see it. But everything over here to the left, including these extra 2 rows, those are all metals. There's one exception, which is hydrogen up here. It is the only metal, non-metal on the metal side. And we'll talk more about why that is in another video. Metalloids are the things that touch the stair step. So they're kind of metal-like elements. And then non-metals are everything to the right of the stair step over here, which are a lot of gases and liquids. All right, each box on the periodic table represents one element, and they are called an element key. And there's a lot of information that you'll need to when you look at an element key. The number at the top is the atomic number, which is the number of protons in one atom of that element. The middle letter or letters is the element symbol. And then the bottom number is the atomic mass, which again is the weight of the average number of protons and neutrons. So, if we want to think about how many protons, neutrons, and electrons are in the atom of an element, well, it's pretty simple. If we want to know how many protons there are, we just look at the atomic number. The atomic number is the number of protons. So for example, carbon's atomic number is 6. So there are 6 protons in every atom of a carbon. The reverse is also true. If there are 6 protons, then we know it has to be carbon. The number of protons is what identifies that element. Electrons, the number of electrons is equal to the number of protons. Atoms are not naturally charged, and so the protons which have a positive charge have to balance and match the electrons which have a negative charge. So carbon's atomic number is 6, so that tells us there are 6 protons, which means there has to be 6 electrons. Now, neutrons is an extra step, but not difficult at all. So we take the atomic mass, and that equals the number of protons and the number of neutrons. We remember electrons don't have a lot of mass, so we kind of disregard those. So you basically subtract the number of protons from the atomic mass. We round the atomic mass to the nearest number. Carbon's atomic mass is 12.011, so we round it to 12. And the atomic number is 6. That's how many protons there are. So 12 equals 6 plus the number of neutrons. So the number of neutrons has to be 6. In this case, the number of neutrons is the same as the number of protons, but that's not always the case, not always equal. So for example, lithium's atomic number is 3, its atomic mass is 7, so 7 equals 3 plus the number of neutrons. So the number of neutrons in that case is 4. A couple examples of special types of atoms. One is called an isotope. An isotope is a special type of atom that has more or less neutrons than the typical atom. So for example, carbon typically has 6 protons and 6 neutrons, as we just saw in our calculation. However, sometimes we can make carbon atoms have 7 or 8 neutrons, but they still keep their 6 protons. Remember, it has to have 6 protons in order to be a carbon atom. If we change the number of protons, it becomes a different atom. So we can add or subtract these neutrons, and that makes what is called an isotope. Isotopes usually act like the regular atoms of the element, but a lot of times they're unstable or often radioactive. Whenever scientists are trying to work with atoms and chemicals and elements, a lot of times they're working with isotopes. The other case is ions. Ions are a special type of atom that has a charge because it has either gained or lost electrons. So we saw isotopes happen when we gain or lose neutrons. Ions happen when we gain or lose electrons. This comes into play when atoms start bonding with each other to form compounds and molecules, which we'll talk about in the future. Remember, all atoms are neutral and with no charge because they're equal number of protons and electrons. The positive and negative charges cancel each other out. When an atom gains one or more electrons, it becomes negatively charged because it gets more of those particles that have a negative charge. When they lose one or more electrons, they become positively charged because the protons are outnumbering the electrons. And again, that comes into play when atoms start bonding with other atoms. Here are some common elements and their symbols on the periodic table that you should recognize. I'm not going to read through those. You can see them there, but those are some you just want to become familiar with. A few exceptions. Most of them are the first letter, hydrogen, helium, carbon. A few exceptions because of the name of that element in a different language is what was used to pick the symbols. So for instance, iron, Fe, that comes from the word ferrous, Ferrous. Silver, Ag, gold, Au, sodium, Na, and mercury, Hg. A few exceptions there. Of course, there are more, but these are some of the basic elements you should recognize. Fun few facts. Carbon is an extremely important element for life. It can form up to 10 million different compounds. We are carbon-based life forms. The molecules and atoms in our body, a lot of are carbon-based. One element that you don't hear about too often is called francium. It was named after the country France. It is the rarest element on Earth, and there are probably no more than a few ounces of it at any given time anywhere on Earth, which is kind of interesting. The only letter not in the periodic table is the letter J. So any of you J fans, none in the periodic table there, maybe in future elements that are discovered. And we were just talking about elements and their symbols and the exceptions, and silver was one of them. Silver, which is argentum in Latin, the country Argentina was named after that. So the silver gets its symbol Ag from the word argentum in Latin, and that's where Argentina got its name. And finally, although there's helium on Earth, it was first discovered by observing the sun. So not even kind of really figured out here on Earth, but by seeing the sun. All right, so those are some of the basic facts that we're going to start out with about the periodic table. In the future, we're going to move on and talk about all of the different groups. Remember, columns of the periodic table are called groups, and we're going to talk about some of the properties each group has, because that's the whole purpose of the periodic table, is that they are arranged by groups that have similar characteristics. Be sure after when you are done watching this that you look and review your notes, go back and rewatch the video if need be, add detail, add color, rewatch key facts or key sections if you need to, and then do your reflection. I will be checking both of those for your homework completion.